All right, let's start a recording to make sure we keep track of this for anyone who can't join us live. So, hello. Um, what I wanted to do is just kind of touch base and wrap up from this past week and get us ready for the upcoming week and give you guys a chance to ask questions and so on. So, we'll talk about what's coming up next at the end, in case there's others who might be joining us still. But here is our schedule. So we're moving into an aldol reaction. And I have this listed here as a Beyond Labs experiment, and the Beyond Labs is so-so. So I think we're just going to we're going to do this as another notebook exercise to get some more practice working on the notebook, since we're not in lab and doing that every single week. So we have that. We're gonna do that instead. So we'll talk about that in just a minute. Let me talk about what's due today to make sure we are all on board with that, because some of you are still turning that in. So the lidocaine handout has on the bottom here, it has for the lab report. So it has your notebook pages. So that is your pre-lab and your procedures and your observations. So the stuff that you turned in for the pre-lab at the very beginning, I've gone through that and given some feedback. So you can take a look at that and see if there's anything missing. You can, make up for that and include that in your final report. You don't have to do a complete results and discussion, because we don't have, like actual individualized results for each of you that you would need to discuss and saying, oh, my yield was really lousy because I spilled half of it when I did this and so on. So, so that's not something that we're going to try and simulate in a remote experiment. So the lab report. So these pages, the lidocaine synthesis questions, that will mostly pretty much constitute your lab report, because in this I ask you to evaluate the NMR and IR data for part 1, calculate the theoretical yield, and then that was the NMR and IR of the starting material, and then the NMR of the product of part 1. Now, some of you already did that last week, which was awesome, and you didn't have to do that today or this week. And then we're adding on to that the part 2, calculate the theoretical yield, and then answer some questions about why we're using the excess amine and that kind of thing. So the part 2 questions, a couple things that came up today and a couple things I just want to make sure I point out. So your theoretical yield, the way we're calculating the theoretical yield of the final product, the part 2 product of lidocaine, is we use the amount of starting material that we had in part 2. And where do you get that? That's the amount of the product we got in week 1. So this is, how multi-step syntheses work. Is you can't really prepare for next week's lab until we finish this week's lab, because the product from this week is going to be the starting material for the reaction next week. So in Blackboard, I told you the amount of product that you're going to get after week 1 that was isolated in week 1. That's what you need to use to do your table for part 2 and do your calculations for the theoretical yield for part 2. So if you did not do that, so I know some of you already submitted your lab report, you could resubmit to Gradescope without a problem. So if there's any correction you need to make to that, you can resubmit that to Gradescope. So does that make sense? Do you see what I'm saying here? In case I wasn't clear with that last week when I posted those numbers to Blackboard. So your theoretical yield of the lidocaine is based on the amount of product we got for the part 1. Then we have some explanations here for why we need the excess of amine. So what can help with that is maybe looking at the mechanism of that reaction for that part 2, analyzing the NMR for part 2, and then getting into that some detail about the precise workup steps to isolate our lidocaine product. And so this has to do with the acid-base extraction. So remember the Blackboard quiz that I had you work on and the tutorial for acid-base extraction. So really understanding how those acid-base extractions work, really practicing and practicing and practicing with the quiz. It's still available. You could still keep practicing that and getting some information from that. This is where we're applying it, is we're using that process to isolate the lidocaine, and how precisely is that working? Okay, and for the most part, what we're looking about, remember, like dissolves like, and so deciding if a given compound will dissolve in the organic layer or the aqueous layer. The overall theme, of course, is that like dissolves like, so we expect any organic compound to be in the organic layer, right? That makes sense. The only time a neutral organic compound would be soluble in an aqueous layer is if it's a very, very small organic molecule. So it has very, very small nonpolar parts. So little tiny molecules like acetone or ethanol or maybe isopropanol. These are things that are miscible in water and have good water solubility. But when you look at a big structure like lidocaine, you know, or something with I think maybe the cutoff is maybe 5 carbons or more. These are things that typically are not soluble in water and would only be in the organic layer. One interesting exception to that is if you look at the structure of like sucrose, you know, or sugars, those are actually quite large organic molecules with many, many carbons, but every single carbon has an oxygen attached. There's an OH, 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 OH. So it's an extremely polar molecule, can do tons of hydrogen bonding. And so again, thinking of like dissolves like, that's why those are so readily soluble in water, even though they are, you know, it's a neutral molecule. Okay, so with the overall observation that typically an organic molecule will be soluble in an organic solvent, so that we would find it in the organic layer if we did an extraction, and not in the aqueous layer, not in water. Okay, we can use acid-base extractive techniques if we have a functional group on that molecule that is acidic or that is basic. What we could do is we can add a proton to that molecule or remove a proton to that molecule to make it charged. And so when you have a charged organic compound, an ionic compound, that now is something that would love to be in the aqueous layer, because and not in the organic layer, because it'd be too polar for the organic layer. It wants to be surrounded by water molecules to stabilize those charges. Okay, so when you're looking back to those Blackboard quizzes, if you want to continue working on those as you're fine-tuning this, if there's anything you want to, you know, think about if you're still working on this to submit it, is thinking about whether or not a given molecule will be charged. And if it's charged, that's when we expect it to move to the aqueous layer and not want to be dissolved in the organic layer. Okay, so hopefully that, you know, can maybe resolve some confusion you had about questions 8 and 9 or about those Blackboard quizzes. And you'd be able to answer questions like that and explain things like that in the future with confidence. So any questions that I have not addressed about the lidocaine report that's due today? We're good. You can unmute yourself anytime, just jump in. We are good. Awesome. Oh, and so then the other thing, so when I said the note, so those 1, 2, 3 pages, if you want to include this 4th page, that's fine too. If you did some drawing on here, that's great. But just those 3 pages are required for the lab report plus your notebook pages. So then someone asked, well, wait a minute, how about, I said you don't need the results and discussion, you know, for your notebook pages, just your procedure and your observations. But I did include the amount that you isolated at the end of part 1 and the amount you isolated at the end of part 2, so we can include that in our observations. And then the one thing that we could do is we can calculate our percent yield. So normally that would be like in our results section, but you have, for each part you have a theoretical yield, and now we are given the actual yield, the amount obtained. And so we could use that to calculate our percent yield. So please do that as just the last little part of your observations. And that's that's all the evaluation we need to do of our notebook. We don't have to do anything beyond that. You don't have to, because I know that in the handout I had, your results and your discussion and your references and those sorts of things. And I'm not going to be evaluating any of that. But please do calculate your percent yield. I didn't include that in this handout because I wanted this handout to be as generic as possible for all the instructors at Cal Poly to be able to use, and not everyone is going to want to, do that part. And but then I forgot that it was still in this generic form, and I never told you what to do with those numbers. So thank you for calculating the theoretical yield. I'm the actual yield for both those parts. Some of you also mentioned that you're having trouble because you have this PDF and then you have your whatever document you use to do your lab notebook. And in Gradescope, I have just one form for a PDF. And so what I can do is I'll open up a second assignment in Gradescope, and I'll just call it like lidocaine supporting documents, and just give it a generic name like that. And so you could upload the the report pages to the original one, and your notebook pages can go here if you can't get it all into one PDF. Okay, the easiest for me anytime I have various documents like that is to just print stuff out and then just Genius Scan, snap, 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 snap. I can take those 10 pages and make it into one beautiful PDF ready to submit anywhere. So that's an option, but I know not everyone has printers, and I don't want to, I'm trying to not make this, I'm trying to make this as easy for you guys as possible. So if you can submit it as a single PDF, that's great. If not, look for a second assignment that I'll call notebook pages, and that's where you can submit the notebook pages as a PDF. There's also, I don't know, Paul, if you tried Zoto. Is Paul here? Yeah, Paul asked about PDF, how to combine PDFs, and I told him about a free program called Zoto, because not everyone has like Adobe, the full Adobe Acrobat, where you can manipulate PDF files. So I've been using Zoto as a PDF editor, and I found it to be very user-friendly, and I actually like it a little better than Adobe Acrobat. So you can maybe try that if you want to try combining PDF files. But I think just having the second assignment there in Gradescope should handle everything. So I really don't want it to be, I don't want you to be spending, an hour just trying to manipulate your documents to upload them. That's not where you should be spending your time. So while it's great to learn some new technologies and have that information moving forward, do know that if you can't make it all into one PDF, that shouldn't be a problem. I'll put a second assignment together for you and have that available. All right. Sound good? Questions about what's new today? Please go ahead.
I have a question on the Hydride lab.
Yes.
So on Blackboard, it says that it's out of 20. But on Gradescope, it says that it's out of 15.
Okay. That may be because I had 5 points for, let me see if I have, can I find Gradescope here somewhat easily? There it is. So we had the Hydride pre-lab, and so I think maybe I included that. I'll check.
Okay.
It's funny because in Gradescope I don't have the there's no grade book in Gradescope, so I can't see the big picture. So I set up these assignments, and they're all these little independent silos, and you never see the whole thing on how many points everything is. So that's something I need to do, is sit down and list out everything with the points. And I'm going to actually do that for my lecture class too. For those of you in my 3150, I'm gonna just start making a master list of, these are all the assignments we've been going, these are how many points there are, and that way you can keep track of things as we go along, and the points as well as I can. So what I'm trying to adjust is some labs end up a little, when you're looking at it, the Greenyard lab was a 5-page thing and the Hydride lab was 2. And so I'm trying to make sure that the points you're being rewarded for the time you're putting into these labs. So to just say across the board, like, okay, every lab's gonna be 20 points, that might not really be fair, because some are requiring more time. So that's what I'm trying to do, is trying to reflect that. And so at the beginning of the lab, or the beginning of the semester, I just tried to make my best guess here and there. And of course, at the end of the semester, I'll know exactly, oh, this assignment was a little meatier and so on. Or this one had, like the hydride had, oh, it had this SDS assignment and that was separate. So I'm trying to sort all that out. So thank you for pointing
Yeah,
out. I
because
will.
on Blackboard, the SDS is a different assignment.
Mhm.
So I was worried because I was like,
Exactly. So I will sort that all out. I promise.
okay.
I
Thank
promise.
you.
Thanks for bringing that to my attention. More to come. I'm doing my best to like stay afloat week to week. I'm sure, just like you guys are. So, that's one of the big picture things that I thought would be a really good idea. So I agree with that. Um, okay, so back to grade school. Any other questions then about what's due right now?
Yeah, I have
Or
a question.
go ahead.
For the lidocaine lab, I see that you could submit a picture like corresponding to certain questions. Would you prefer it like that or just one single PDF?
So a single
Like I could
so you
select,
can do a PDF, and then when it says like, what do you have for question one, you could point to a certain page on the PDF if it's split up. So
okay, because
what's
here I could see it, like I could select images for like 1 to 2 and then 3 to 4.
exactly? So just on a PDF, just point to where that is on the PDF,
Okay.
if that works. So here's the tough thing is we all jumped into Gradescope as instructors, but we've never once seen it from the point of view of the student. So we're trying to set up our assignments, and then when there's a mismatch, you're like, well, what's going on? And we don't see it from your point of view to give you the proper instructions. So that's where I'm lacking. And I'm thinking, like, so again, another great to-do list would be for, us to make a course for all the chemistry faculty and put an assignment in there so we could see what it looks like when you upload something and how it works. So anyway, do the best you can to make it. If there's a way that you can figure out how to make your PDF match this PDF, that would be awesome. And if it doesn't, that's fine too, because I'll just search through and I'll find it in your submission. Um, the tricky part is if I have a template and I know that what you're submitting is going to match the template, then that's fine. But because you are going to be also submitting your notebook pages, I didn't, I don't know how many pages are going to be submitted, and we no longer have that direct match. So that's when Gradescope now is reaching out to you saying, okay, you submitted these 10 pages. Where could I find, questions 1 and 2?
Okay.
So if it lets you pick one of your 10 pages on that they'll find 1 and 2, then that's great. And it says, okay, how about 3 and 4? Oh, that's also on page 1. And 4 and 5. Oh, that's here. If it lets you do that, that'd be awesome. And you can let me know what that looks like, so I can do a better job of
Yeah, like
explaining it.
it gives an option to like, so I could submit like 1, 2, 3, like 5 different images separately corresponding to each of the questions.
Okay,
So
interesting.
if
And
that's
so
easier, I can do that.
yeah, so
Okay.
if that's an option and you can figure out how to do that, that works the best on my end as a grader,
Okay.
because what I do is it sets it up so I grade everyone's question 1 all at once, and that way as I'm flipping through the submissions, it automatically brings up what you said was question 1. So
Okay,
yes,
got
if
it.
it's possible to do that, that would be great. Very cool. Very cool. All right. Any other questions about our lidocaine? All right. So we are back to having an NMR problem set. We had a couple weeks off, but let's get back into that for a little extra practice. So this is in Blackboard and also on the webpage. So you can find that here. So this is NMR problem set number 4. And let's see if we can do our best to not only identify all the protons on our structure as A through F, but also all the carbons on our structure. Maybe you could draw a second, because I know it gets kind of messy. Maybe you could draw a second copy of your proposed structure and then point to each carbon atom and say, oh, I think this is carbon 1 and this is carbon 2 and this is carbon 3. And sometimes you can't really distinguish. You're like, I don't know, this is carbons 2 or 3 or 4 or 5. You can group them together. Carbon, we can't be as precise, but I want to see if you can maybe take your best guess at assigning some of those. That would be a good exercise. And then paying attention to our instructions here. So again, that last step after you've put everything together and you've proposed a structure, then go back to it and predict for each proton, point to it and say, okay, I'm expecting this based on my structure. This should be a triplet, and it should be, you know, around 3.8 because it's next to an oxygen or something like that. So predict what each of those should be using your tables, not using your data. So I don't want it to say, you know, oh, it should be around 1.7 because that's where E is. No, what does the table say? And then you say, okay, it says it should be 1.2 and it's at 1.7. So that's pretty close. I think that's a good match. So I really want to get you in the habit of using your tables as you're working on these. And that's the way that I can verify that you've used your tables. So, so this will be, I don't think I've set it up yet in Gradescope, but this will be due next week on Wednesday. And let's see. Oh, I wanted to talk about, oh, that was the other thing. So yes, the lidocaine quiz that we had last week for the part 1, there was the question. So that's been graded, and you can see that that grade and feedback in Gradescope. If you ever have any questions about your grading, please don't hesitate to submit a regrade request through Gradescope and ask me a question that way, or ask me to reconsider or anything like that. Someone caught today that I didn't click the right button, and I gave no credit for their pre-lab notebook pages. And so they said, well, why is this a 0? And so I was able to fix it and right away. So please don't hesitate to ask, because those are the kind of things, if I had office hours, you know, and that open door, you'd come in and we'd look at it together and we'd figure these things out. So that will be our mechanism for the, you know, dropping in the office and saying, hey, what's up with this? You know, can you explain this? So please know that feature is always available to you. Plus you can email me. Plus you could, you know, drop it in office hours, but that's kind of an official way for me to check a grade and maybe adjust a grade if needed. So anyway, one of the questions on the quiz asked about why are we using the acetate? Why are we using the acetate at the end? So the acetate that is added at the end, I asked you to calculate that. I asked you to calculate how many moles of the acetate we used. And if you looked carefully, you would see that actually it's a pretty small number, the moles of acetate that we're using. And the key here is that the purpose of that acetate is to deal with any of the unreacted starting material that may be left. So let's go back to our reaction. This is part 1. So I know this is quite a while ago. Part 1 was formation of the amide. So we start with dimethyl aniline. We have 2 leaving groups here, but this acid chloride is far more reactive. And now, for those of you who are in 3150, or if you're taking it right now with me, this is finally a reaction like, oh, hey, I could actually recognize what's going on here, because I know we started this lab a couple of weeks ago before we started chapter 20. But what's happening here is the amine is adding into the carbonyl, and then we have a CTI, ding, 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 ding. We have a CTI that actually collapses back down and kicks out the chloride. So we're doing an acyl substitution, and we're making an amide. Where we used to have an acid chloride, we now have an amide. We'll see lots more examples of reactions like this in tomorrow's problem solving session. So, so we make the amide. We're pretty much, when you look at the reagent table, we pretty much mix these 2 guys in a 1-to-1 ratio. Neither one has a huge excess. I think this one has like a 4% excess. This is like 25 millimoles compared to 24 millimoles, right? So they're not exactly 1-to-1. This has a very small excess. So in theory, we should consume all of the dimethyl aniline because it's our limiting reagent. But it's possible that we might have some of this left over. You know, maybe this acid chloride was contaminated. Maybe some of it had degraded. There's all sorts of reasons that a reaction doesn't go exactly to 100%. So the question is, how do we remove this contaminant to make sure that the product we isolate doesn't have it mixed in there. Okay, so that is what is discussed here, and you can reread through this, in more detail later to make sure you're really getting it. Because this one question about the purpose of acetate, I think it was a 2-point question, and I think maybe one person out of 20 got the full 2 points. So nearly everyone had some part of the problem that was missing. And here's what I was looking for. Okay, what is discussed in this write-up is that this is our unreacted starting material, right? And as the chloride salt, because we have HCl that's formed in the reaction, as the chloride salt, this is insoluble. So this will precipitate out of our mixture. Well, how do we isolate the product of that first reaction? The product is insoluble. The product just crashes out and we filter it off. That's our entire workup, is to filter off our product and maybe wash it. So if we have our product here, this product is a precipitate that we're collecting, and we have some of this unreacted starting material that also precipitates. Then the product the solid that we're isolating at the end of the reaction is not pure. So what we do, the clever trick we do, is we add in the sodium acetate, and so that replaces the chloride ion with an acetate ion. And so by changing the counter ion, it now makes this soluble. This is no longer insoluble. This is going to be soluble in the solvent. And so when we filter off the product, this unreacted starting material gets filtered off and doesn't get collected with the product. Okay, so for the full 2 points, I needed to see, when I asked to see the artwork, use drawings to support your answer. These were the drawings that I was expecting to show the chloride salt versus the acetate salt. And then the discussion had to say something about removing this unwanted, contaminant, or this unreacted starting material, and removing it by it was going to co-precipitate with the product, and now it's not. Now it's soluble. So it actually said in the question, I specifically prompted. Sorry, I don't have the quiz with me. In the question, I specifically asked you to address the solubility, issues going on here, and that was it. So you can read through this a little better to fully explain that. But that's but don't feel bad if you didn't get full credit there, because most people were missing this. But it's right here clearly on the difference between the acetate salt and the chloride salt. So this is about reading through the instructions very carefully, and that's very important too when you're doing a lab, is to, let's say you have a lab textbook that you're following. It's to not just like jump right to the procedure and just write out the procedure and now I'm done, right? It's reading the whole chapter, reading the whole introduction. It explains why we're doing what we're doing. It explains the mechanism. It explains the purpose for the steps that we're doing. And that's really the goal, especially of a second semester lab, is to get you working independently and get you understanding why we're doing the steps we're doing. So do make sure that you read through thoroughly any handouts that are provided. All right, questions about that quiz?
I had a question about the first question, asking if the product is a solid or liquid.
Yes.
And then giving the 2 pieces of evidence. It is a solid, right?
Yes, it's a solid, and the 2 pieces of evidence that I was looking for is right. So if we look at the procedure here, so one bit of evidence is in the procedure, and the procedure right here that is relevant, is we isolate the product by vacuum filtration, right? So write that there. That's telling me that my product just precipitated out, and I'm isolating it by filtering, which means it must be a solid, because I can only do that with a solid. Okay, so one bit of evidence was in the experimental procedure. The other bit of evidence was in our reagent table, because when you looked up the physical properties for this compound, you should have its melting point, and its melting point is above room temperature, which means it's a solid at room temperature. You have to heat it up to that melting point in order to make it a liquid. So those are the 2 bits of evidence that I was looking for.
Okay, thank you.
Very good question. Let me see if I had any other notes about that one. I think that was all I had for those notes. Okay. And no R&D. Okay. So I think that's all the announcements that I had for the feedback I wanted to give you for the quiz and notes for notes about today's lab that is due. And so next week, or starting this week, we are now, we're in Aldol week. And what again, kind of how things used to be when we're just meeting once a week and we have like this, here's your pre-lab stuff and here's what we're doing today and here's what you have to do for next week. I'm really just gonna reorganize it and really simplify it and say, okay, week 7 is officially starting today. So that means everything that we did in week 6 is now due today. And today is when I'll kick off our next topic, and then you have the whole week to do that. So I'm not going to require like, oh, this is the stuff this pre-lab stuff you have to do before today because we're going to have our quiz today. We're just gonna throw out that organization that I was kind of had in my mind at the beginning of the semester, and we'll just say, okay, today is where we start our Aldol. So if we look at Blackboard, let me see if I can find that somewhere here. Do I have our Blackboard? There's our Blackboard site. Nope, that's our course site. Oh, shoot. Do I have Blackboard anywhere here? Dashboard, Grade Center. Oh, there's my Blackboard. Let me see if this will let me. If I am logged in. I am not logged in. All right. So, where am I? I am nowhere. I was here. I thought I was here. No, I'm not. Okay. All right. So in Blackboard, sorry, I don't have a screen with me. Oh, you know what? I can share my other screen. Let me share my computer. If I could find my mouse. Oh my gosh, I have 3 monitors. And here they are. Okay, let me drag this over here and make it a little smaller. And then let me share my screen with you. All right, so this one I can't draw on, but that's okay. All right, so can you see this this Windows Explorer now with the Blackboard?
Yes.
Is that showing up? Thank you very much. Okay, so I can get rid of my little chat window here. So when you go to week 7 for the Aldol reaction, I have it broken up kind of in the traditional fashion. But the timeline for all 3 of these parts is, between today and next Wednesday. But I kind of have it broken up again, just kind of mentally. If we're picturing like, okay, we're gonna watch when I would be going to lab and doing this experiment, that's what I'm gonna be watching the video of someone doing the experiment for me, right? So I have the luxury of staying at home and not having to wear my safety goggles. Okay, so before you do that lab, here's the stuff you would do before. So before you watch the Aldol video, here's what you want to do. So I have a link here for the procedure. Okay, bye-bye. Sorry. I have the link here for the procedure. And for the procedure, it goes through, talks about the experiment we're going to do, and it actually has 2 possibilities. And we're just going to look at this first one, the root A, the typical one. Okay, so I'll specify that in Blackboard. I forgot it had this second option. So so we're going to do root A. So this has again, kind of the handout, the explanation, the description, and then the experimental procedure. So so you would in your notebook you would write that up, and then there's a couple techniques that are pertinent to the procedure in this experiment. One is looking at UV-Vis spectroscopy. So I provided a link here that kind of gives a background on UV-Vis. And the 2 techniques that are important here is recrystallization and melting point. So you could go to the techniques manual that you have, or a textbook, whatever you have. read through, review, because it's been a while since you've, done these experiments in first semester lab. So what does it mean to do a recrystallization? What are the steps to do a recrystallization? How do you take a melting point? Those kinds of things. What does that data tell you? Okay, so review those techniques, and then I have a Blackboard quiz where you can test yourself on it. And I've set this up like my other Blackboard quiz, where you could just take it as many times as you want and get that feedback and get good at it. Okay, so this is a chance for us to revisit that technique and make sure we remember how it works and what we're doing and why. So after that is kind of your pre-lab activity. You're like, okay, I got this, I'm ready. Let's now go do our lab. So doing the lab is just watching this very short video, and that's where you can record your observations in your notebook of what's going on. And I've given you some experimental data about how much product we get before initially and how much we get after recrystallization. And here's your melting point. And I'm not gonna have you I'm not gonna ask you for the mechanism, because we're actually a little ahead of, let's take a look at the reaction. Here's the reaction that we're doing. This is called an aldol condensation. And so for those of you who have finished Chem 3150, you can actually, hopefully, propose a mechanism on how we get to this product. And in the video, they show a mechanism, but it's not really, there's some errors in it. So, so maybe you could spot the errors, and we could talk about these errors a little later as a class, okay? But I recognize that for those of you who are currently taking 3150, this is chapter 21, so this is what we're gonna do after the midterm. And then at that point, we'll see this reaction, we'll know it inside and out, and that'll be great. But for now, I don't wanna fill your brain with extra mechanisms that don't make any sense for you right now. So anyway, I'm not gonna be asking for that mechanism, but for those of you who are finished, maybe you can spot the errors. And then after you're done with the lab, then I provided an IR of the starting material, and I'm going to have a lab report PDF for you to do. Now, I don't, I have an older version, but I want to modify it a little bit for the remote lab. So I'm going to continue working on that and have that for you in the next couple days. So whenever you're ready to do it, it's available, but it won't be due till next Wednesday. So I don't have that available yet. But I do have the link for the NMR homework that's due next week. Okay, and here's the link for the aldol, pre-lab quiz. So normally I would have you do that pre-lab quiz before we met face-to-face, and then in class we would have an open book quiz where we're doing it all synchronously. But hey, let's take advantage of the fact that we're remote and the fact that we can do things asynchronously. So I'm going to let you do it according to your schedule. So if you don't want to do any other lab today after we're done with this little synchronous session, if you're saying I'm done with lab today because I got a midterm tomorrow and I got to crank on that, then that's fine. Nothing else is due today. All of the aldol components are all due next week along with the NMR. And then next week's lab, we're going to do mass spec. So actually next week is not an experiment. We're going to learn a new analytical technique called mass spectrometry. And so once again, I'm not going to say, and on top of that, I want you to get ready for the mass spec lab. Just worry about aldol this week. And then next Wednesday, we're going to meet synchronously, probably for a couple hours, because it's kind of a, well, I take that back. I do have some of that recorded on Educator. So I do have that lecture. I'll review that and make sure that's suitable. So we'll just do, we might just do a touching base and launching you for the next component. Okay, which means, if you can't make it at the live session at 3 o'clock, you can watch the recording, and that's perfectly fine because we're not doing anything synchronously. But watching the recording means you don't get to ask questions, when they pop up when I'm explaining something. So it is kind of nice to, if you can make the live session, that's always nice to be able to do that. Okay, so does that make sense about what we have coming up then with our aldol lab? Any burning questions there? Anything? You can unmute yourself, jump in if you have some questions to ask. Let's see. So the aldol, like I said, the mechanism is a little strange and looks a little weird for those of you who we haven't jumped in there. But what we're doing is we're doing a nucleophilic attack on this carbon. That's our electrophile. And our nucleophile is going to be obtained by deprotonating this carbon next to the carbonyl. It's called the alpha carbon. So we're going to make an anion here, and that nucleophile then can attack this carbon. And then if we lose water, if we eliminate water, we could get a double bond here. And it's actually going to happen to both sides. So both of these alpha carbons are going to be nucleophiles, and they're going to react with two equivalents of our benzaldehyde. So keep that in mind when you do your reagent table. Take a close look at this product. Notice that this, to find your limiting reactant, right, you require 2 moles of benzaldehyde for every 1 mole of acetone in order to make 1 mole of product. So keep that in mind when you're comparing your molar ratios to see who in fact is the limiting reactant. Okay, so otherwise I think that's everything I wanted to say. I think that gets us set up for moving forward. Any other questions, you're welcome to email me anytime. I'll be available the rest of the day. Otherwise, I think we're all set. Sound good? Questions? All right, very good. We'll wrap up then. I'll stop the recording. I'll stick around though. If you have other questions, you're welcome to